Hi there, I'm going to do a quick example about polynomial long division. You're going to see it in module 2, like homework 8.3, 8.4, and it says polynomial division. And yes, I know I have ashes on my forehead. I didn't smudge myself, I haven't made a makeup mistake, but today's Ash Wednesday when I'm recording this and I've been marked. So that's, I'm aware. Okay, so let me see. What I want to do first is go and just remind you what long division looks like in case it's been a minute since you were in 5th grade or whenever it was that they first taught it to you, and you may have been shown something completely different than the method that would be most useful to build upon for the polynomial division. So first of all, this is an example of when you need to divide one polynomial by another polynomial. Okay, so in this case, we have the thing that's being divided. That's called the dividend. I guess I'll just do some terminology real quick here. The dividend is like the big thing you start with, and then you divide it by something called the divisor. Think of it as the divider. You're dividing this big thing up into this many pieces, except we're dealing with variables instead of numbers. Okay, so we've got this cubic dividend divided by this linear binomial. Okay, so before we get into that, let me do a quick numbers example, just to remind you, because when you look up the view and example, it's going to do the steps based on this method of doing long division. So let's do 3,045 divided by 11. I'm going to pick something that's kind of easy to kind of calculate in our head. All right, so when we set this up, of course, we put the dividend. I should probably have left more room here. You put the dividend under the little divide box, and then what you're dividing into it, you put on the outside. So we're dividing the 11 into this number, and we just kind of go bit by bit. We don't want to try to do the whole thing in our head. We just go in little pieces, and we continue to bring down more numbers. So we start from the first digit, and we just keep moving until we get to a number that's big enough for 11 to divide into. So 11 doesn't go into 3, but 11 does go into 30, since 30 is greater than 11. Now we have to think, what's the most number of times 11 goes into 30? What's the most groups of 11 can we get out of 30? So we know 2 11s are 22, 3 11s are 33, which is a little bit too big. So it goes in 2 whole times. So I'm going to write the 2 up here, and then we multiply. I just said a minute ago, 2 groups of 11 is 22. So we're going to write the 22 underneath here and see that's how many whole times it goes in. And we want to know what the remainder is, what's left over. So once we do the multiplication, then the next thing we always did was take the difference between what we got here and what we were building on. And we want to make sure that the remainder is smaller than what we're dividing by. If it's bigger, if it's 11 or bigger, we should have increased this number up here by 1. All right, so a remainder when we subtract the 2 groups of 11 from the 30 is 8. And then what we would do is continue just one at a time to bring down the additional digits. So now the 8, we're going to build on 84. Then we do the same thing all over again. How many whole 11s do we get in 84? How many whole times does 11 go into 84? Well, that would be 7, because 7 times 11 is 77. 8 times 11 is 88, which is too big. So 7 whole times. So I'll write the 7. We're building our quotient up here. So the answer that we're dealing with will have a quotient and a remainder. Okay, so 7 groups of 11, we just multiply. 7 times 11 is 77, and we write it down because we want to see what the difference is here. So it goes in 7 whole times with, we subtract 84 minus 77 with 7 left over. So it goes in 7 whole times. 7 times 11 is 77 with 7 left over. You subtract to find the leftovers. And we just keep doing this until we run out of digits. Okay, so we have one more digit, it's a 5. So we bring that one down and we do one more round. Now we're going to do the same set of questions one more time. How many whole times does 11 go into 75? That would be 6. 6 times 11 is 66. So there's my 6 groups of 11. And then we always subtract that. That's going to give me 9. There's nothing left to bring down. So we are finished with bringing numbers down. So we're finished with the problem. So 9 is what we had left over. If it had gone in perfectly evenly, then these numbers would have matched and we would have had 0 remainder. So we have 276 with a remainder of 9. So if you ever wanted to check that, I think they have check in the homework for this polynomial stuff. I don't know if you actually have to work it out or they just do it in the example, but you would take the number of whole times it goes in times your divisor. So you do 276 times 11. You work that out, and then there was 9 more left over. So if we do this, that should add up to our 3045, and I believe it does. So 276 times 11, just to prove it to you, 3036. And then of course, when we add our 9, that'll give us our 3045, which is the original dividend. Okay, so this is long division with just pure numbers. You put your dividend inside the box, you put your divisor, what you're dividing by, on the outside, and then you just kind of take just the minimum number of digits that you need that's a little bit greater than this. In this case, we'll be going by 2 terms at a time. All right, so let's do the example with the polynomials. So let's set it up the same way. Our divisor goes on the outside, it's x plus 2. So we're going to do x plus 2 out here. And then under this, we're going to write the dividend, which was that cubic. So 6x cubed minus 4x squared plus x plus 7. Just writing that down. Okay, so now we're going to do this the same kind of way. We're just going to focus on the front term here. Okay, so we're just going to say, how many times does x go into 6x cubed? Okay, it's the same thing as saying what times x makes 6x cubed, or it's the same thing as dividing 6x cubed by x and see what you get left. So in any case, it's if you had to kind of do it off to the side, you would do this, you would cancel one of these and get 6x squared, or you could just say x times what makes 6x cubed. Okay, so x times, we need a 6 and an x squared. So if I do 6x squared times x, that gives me 6x cubed. So that's how you figure out these terms up here. You just do the front term here on the divisor. How many times does it go into the front term on the dividend, or what times this makes that? Okay, and so now what did we do up here once we wrote this number down? We would multiply and put it below here. So now we're going to take this and we're going to multiply it times the entire divisor and put that right under here. So we're going to do 6x squared times x, get 6x cubed. Then we're going to do 6x squared times 2 and get 12x squared. So since it's a polynomial, if it's positive 12, I write plus. So it's just like doing this in your head, kind of off to the side. I wrote this up above. My divisor was x plus 2, and that's what I'm writing on this row here. There's where my 6x cubed plus 12x squared comes from right there. Okay, now what did we do after we multiplied up here? We did the 2 times 11 is 22, and then we subtracted that product from the row above. So now that we have this here, I kind of have to be careful when I'm subtracting with more than one term and you have possible positives and negatives. Do I have another color in here? Let me do this. All right, so if I'm going to subtract this, then that means all these are going to change signs. Okay. I don't know if you can tell, I've just written with blue. So these should always cancel if you've done this right. So 6x cubed minus 6x cubed, 0. And then this is what you're really trying to calculate, is the result on these like terms here. Always, if you're doing this properly, your like terms should exactly line up on top of each other. You shouldn't have a cubic stacked up over a squared. All right, so we're going to do negative 4x squared plus negative 12x squared. That's going to give us a negative 16x squared. Okay. All right. So now we have, that's what we got as our sort of remainder in the middle row. Okay, so what did we do up here after we subtracted? We did 30 minus 22 is 8, and then we brought down the next digit. So what I'm going to do here is bring down the next term. So the next term was a plus x. So that's what I'm going to write here is plus x. Now I'm going to do that same procedure all over again. I'm going to say, compare the x out in front to this front term right here. So what times x makes negative 16x squared? Well, I need a negative 16 and another x, so it'd be minus 16x. Can you, sorry? All right, so now we're going to multiply. Now that we figured out what goes up here, we're going to multiply and write those two terms underneath. So negative 16x times x would be negative 16x squared. And then negative 16 times 2 would be negative 32x. Negative 16 times 2 with the x. All right, these are supposed to match up because once you do the multiplying, then you're supposed to subtract your thing you just multiplied from the row above. So that's going to change the signs. Of course, when you subtract, that just alters the signs of whatever you're working with. Okay, so the x squared terms should cancel. And then I'm doing 1x added to 32x because it was negative. I'm subtracting a negative. So 32x plus 1x makes 33x. So that's sort of the difference when you subtract the row I just multiplied from the row above. Okay, so now that I have all that, one more round because I have one more term to bring down. So it says plus 7. So I'm going to bring my final term and my dividend down to plus 7. And we're going to do this one more time. And then whatever we have left at the bottom when we subtract, that's our final remainder. Okay, so x times what makes 33x? That would just be 33. We already have the x out here, so it's positive. So 33, and then I multiply. So 33 times x plus 2. So 33 times x, 33x. You always want those to match. And then 33 times 2 would be 66. Plus, everything's positive. So I did my multiplication. Now, the last step is you want to take whatever you get after you multiply every time and subtract it from the terms above. What happened? Well, oh, don't know what happened there, but it's bad. So we're going to subtract each of these, which were positive, so they both become negative. Okay, so the x's cancel out as they should, and then I have just the constants to combine. So I have plus 7 added to negative 66 would be what, negative 59, I guess would be my final subtraction. Okay, so we don't have anything else to bring down. We're out of terms up here, so this is my remainder. Okay, so you'll also know because you're building a polynomial quotient up here. And once you get to the constant term of your quotient, that's all you've got for a polynomial. So the remainder then is what you get at the very bottom when you, how many times can you go in and out of these doors while I'm recording? That's the new question. Okay, so the final answer then, the quotient is 6x squared minus 16x plus 33, and the remainder is going to be negative 59. Okay, so that's how you do what we call polynomial long division. So the answer is about what, 6 times, 7 times? All right, so here we go. That's the answer. So that should help you. Again, I'm referring to the homework from Module 2. It says homework 8.3, 8.4. It says polynomial division. And the question that was asked was really about the very first question, number 1. There's other things that can happen in these, like sometimes one of these, the divisor, one of these polynomials might be missing a term between the highest power of x down to the constant. If that's the case, you put a 0 in there to hold the place. And just remember, you build it one term at a time. You put one term up here, you multiply it against the dividend or divisor, write those terms down here, then subtract from the row above. You'll have one term left here. Then you bring down the next term and you do it all again. You figure out what times this front term equals this front term, and you write that up on the above. Then you multiply that again. Then we subtract, and then we bring down each term. And then when we're done, there's no more terms left. Whatever you get on that final subtraction is your remainder. Okay, so I hope that helps a bit. I will stop sharing and stop recording and get this posted as quick as I can. So ta-ta.